All right, welcome. How's everybody doing? Bright and early. This is the early crowd, I take it? I think I saw some of you out there running as well. I think there was a 4K or something. Well, welcome to reInvent. If this is your first time at reInvent, welcome. If this is not your first time, welcome back. My name's Henry Hahn. I'm going to take you through DEV203 today. I think technically this is a repeat, but the original talk is actually not until Thursday, so you're welcome to come back to this talk as well. I'm going to be taking you through over the next 50 minutes-ish of talking about how we at Amazon launch applications. So this is a 200-level talk. I'm going to spend a fair bit of time talking about concepts, and then maybe towards the end I'm going to show some demos to make this maybe a little bit more concrete. Just actually a quick show of hands. How many of you have heard of the term DevOps? Okay. I will say that is, in terms of rounding, we'll round that up to 100%. How many of you actually practice DevOps within your organizations? Okay. Fewer hands, but quite a few of them. We're going to talk about DevOps and what DevOps means, why DevOps is important, how Amazon uses DevOps, and how you can get started. That's going to be the overall flow of the talk here. And like I said, we're going to do some demos to give you a feel for some of the tools that we provide to enable you and your organizations to take advantage of agile development methodologies. Before I jump into all this, a couple things. We're going to do some Q&A at the end. So if you end up having questions, we'll have about 10 minutes at the end. There's a microphone over here. If you could come up to the microphone at the end for those questions, and everybody can hear it. Two, we are recording this, so you will have an opportunity to find this on YouTube later on, so you don't have to frantically take notes, or you can put your GoPro down, or whatever it is you need to do to record. And then finally, we do evaluations for all these talks, so if you wouldn't mind filling out evaluations after the talk, that really helps us improve talks in the future and gives us important feedback. All right, so let's go ahead and get started. This, hopefully, is a no-duh slide. There is probably nothing surprising in that sentence of four words. Software is moving faster than it ever has. It will probably be moving faster tomorrow and a year from now. And that's important because organizations that have software at the center of their business, or even to support their business, really can move as fast, or only are moving as fast as their software can be delivered. And that can mean time between the code that's being written to the code that's actually moving to production. And this is important not only for large organizations, but for smaller organizations. And you can even see that small startups that have little funding can still deliver software quickly and to millions of customers. So this is a huge opportunity for businesses to move faster and stay competitive. So really, that's the context by which we talk about the Amazon story for how we launch and build applications. It's really about how do we make that a very efficient process so that we can stay competitive and move quickly. So before we jump in further, I want to talk about DevOps, not in more detail yet, but to talk about DevOps and what the benefits are. In 2015, Puppet Labs actually, there we go. In 2015, Puppet Labs actually ran a survey of high-performing IT organizations, and they found some interesting statistics. They saw that organizations that were using DevOps not only deployed faster, they had shorter lead times, they had fewer failures, and they were also faster to recover. Now, all of these are components to the software delivery process, and the software delivery process being efficient. So being able to deploy frequently, we're going to talk about why that's important. We're going to talk about shorter lead times, how you actually quickly get that software out to production. We're going to talk about failures. Failures happen. That's kind of part of the process, but we're going to talk about how you reduce failures, and then also how you recover if there are problems. So that's kind of the overall context. And those are pretty interesting statistics here. We'll talk about some more in just a little bit. But that is the context, moving the software process along as quickly as you can while keeping it safe and reliable so that you can deliver value to your customers more quickly. All right, so I've been using this term. Normally when you use a term, you're supposed to define it first, but we're going to spend a whole bunch of time on that. And what is DevOps? It's this term that has been used in lots of different contexts. I'm going to talk about it at a fairly high level, and I'm going to focus on 3 big categories. And I focus on these categories because we at Amazon see these as some of the most important parts. These are, 1, a set of cultural philosophies. So within organizations, there are different philosophies about how to approach problems. When we think of DevOps, there are a specific set of philosophies that we think of and we think are very important. There are a set of practices, so very practically, what is the process for DevOps? And then finally, what are the tools that are used within that process? So it's really these 3 pieces that we keep in mind when we talk about DevOps. So cultural philosophies, the practices of DevOps, and then the tools that we use to enable DevOps. DevOps culture. So DevOps is development or developer and operations, development and operations, just kind of combined. And what this really is about is combining the development process and operations. So we'll say historically, development and operations have been separate. You had software application, writing the code, and then you've had potentially infrastructure, the IT, where this application is running. In a DevOps model, we actually combine these 2 things. And this is important for a number of reasons. The item that we say here is shared responsibility. That's really a fundamental part of the ownership of somebody delivering a feature and owning that feature effectively all the way until it gets to production. And not just production as in the code is out in production, but the code is running and it's working and customers can use that. And that's very different than, say, writing some code in isolation and then handing that off to somebody and hoping that it's running correctly in the production environments. So that is one of the core elements, one of the key aspects of the cultural philosophies. It's that ownership and that end-to-end responsibility for those features. Another really big important part is visibility and communication. Visibility really is part and parcel of that ownership. When you're delivering a feature, you need to understand how is that feature, when it's checked in and delivered all the way to production, how is that feature, how is that actually working in production? Is it responsive? Is it available? Can customers successfully use that feature? So you need to have really good visibility. And a large part of DevOps is visibility into your application and visibility into the infrastructure that ties that all together. All right, so that was the high level on the cultural aspects. Now we'll talk about the practices. Many of you have probably heard about microservices. Really one of the key patterns for DevOps is making sure the components that make up your application, each constituent part, whether it's a back-end layer and a front-end layer, are broken up into small enough pieces that they're easy to update, they're easy to maintain, they're easy to monitor, and it's possible for somebody to look at it, a potential end-to-end problem, and understand all the pieces. When you've got a large monolithic architecture, it becomes much more difficult. So one of the key practices of DevOps is moving to this microservices architecture. And we see that this is possible not only for with new applications, but for existing applications as well. I've heard some interesting stories. I was once asked, I think, about how somebody turned a 50-year-old mainframe COBOL application into a microservices architecture. Some are a little bit more complicated than others. Sometimes it won't even make sense to necessarily take that step. But certainly many applications can take advantage of these the microservices pattern. Now, when you have a microservices architecture and you're rapidly making updates, you need a process to make those updates in a reliable way. Every time you would deploy, if you're deploying manually, that's an opportunity for an error. Automation is a key to solving some of these problems, or really eliminating human error from things like deployment. And if you're deploying frequently, which is a good thing in terms of delivering features and improving your software velocity, it really makes sense to automate this because you want to reduce those failures as much as possible. So one of the practices that you may have heard of as well is some form of continuous integration, continuous delivery, deployment. And what this is really about is checking in code and having that code automatically move through the different stages required to get to production, to get to your customers. So that might be check in source, have the source built, have the built code tested, move it to maybe a beta environment where it can be tested further. And then once you've decided that the quality is at the level that you want, you can then move that into production. So you want to make that process as seamless, as fast, and as sort of foolproof as possible. So that is another big part of the DevOps practices. Now, before I mention that in a cloud-based application or a sort of modern application with microservices, not only do you have the application code and the features, but you have the infrastructure where that code is running. Now, when you're running in the cloud, infrastructure is really just code. You can provision new infrastructure through code. So we have a practice that we call infrastructure as code. And what that really means is rather than somebody manually provisioning servers or setting up infrastructure, you can actually deploy infrastructure the same way that you deploy your code. We have a service called AWS CloudFormation that lets you define templates, reusable templates for your infrastructure. So if you know the server types that you like, and you know the VPC that you're going to use, and you know the SQS or the queuing technologies that are going to be used, you can source control that. You can deploy that in the same way, so you have a full record of all the versions that have been deployed, and combine the process of deploying your code and your infrastructure together. Now, one of the last big pieces of DevOps, I mentioned visibility and communication. Your application running in the cloud is kind of this living and breathing thing. It's code, it's infrastructure, it has an experience that your customers have in terms of latency, the distance they have between where they're at and where your application is running. So you really need to have good visibility into the end-to-end experience customers are having. And that comes about with logging and metrics and really the visibility that would tell you if something's wrong. You can, of course, set alarms to be notified if a problem does occur. And when problems do occur, because they will occur, you have metrics and logs to help you figure out what's going on so you can quickly resolve that. So that is one of the other really big pieces of the DevOps story in terms of the processes. All right, so we've talked about cultural practices or cultural philosophies. We've talked about some of these practices. Let's talk about the tools. Actually, I guess to summarize all this, in terms of the benefits, there are a lot of benefits, and those are the benefits that really accrue to helping you move your software into production more quickly. Okay, actually, now we're going to talk about some of the tools. But jumping into that, I want to talk a little bit about how Amazon arrived where it's at today. You will hear about a lot of launches this week. You're probably trying new services. You may have already heard about a bunch of product launches that we've had before reInvent. The teams that are delivering these are using the practices that we're about to talk about, and I'm just going to tell you a little bit of the history of how we got there and why we're using those practices. So between 2001 and 2009, Amazon went under kind of a large transformation in terms of how we delivered software. So we went from a more monolithic, hierarchical organizational structure and application structure to one that is more microservices based. And having now worked in AWS for about 6 years, you see this all over the place. This really comes down to the decoupled services, that's the microservices model, and we internally use what we call the two-pizza team model. Now, if you haven't heard this phrase, basically what that means is teams are structured to be about the size that can be fed with 2 pizzas. We don't specify what type of toppings on those pizzas, but that is the size of the teams that we think about when we think about delivering these. And that's about the size that we see works well in terms of understanding their particular component and taking full ownership of that experience. So we made this set of changes, and we saw a dramatic improvement in the overall process. It's much easier to maintain and update microservices than large monolithic applications. And it's much easier to move faster. But we also saw that there was an opportunity potentially to do even better. So in 2009, we actually ran a study, and it's actually called Understanding Amazon's Software Development Process Through Data. It was, I think John Rouser was the author. You can go find this. But we did this study to try to understand where there might still be inefficiencies. Amazon is about data, using that data to understand how we can improve. So that's what this was about. And we found some interesting things. The process was taking longer than we wanted to, from code to being delivered. And what we ended up discovering is there was a lot of waiting. Now, waiting in software is usually not something you want, especially when you're trying to move fast. So when we looked at this, we saw that after somebody wrote some code, they were waiting for feedback from somebody else. Maybe that was a code review. So they're waiting to get feedback on the code review. And then they make the changes and they try again. They were cutting tickets and they were sending emails, trying to get this response. Okay, well, finally they get their code reviewed. Now it's time to build it. Well, they send it off to somebody else to build it. And they have to wait for that, and maybe they wait hours, maybe they wait days. Somebody finally builds it, they look at the results, fix anything that might be an issue, and then it's time to move that off to test it and deploy it. So you can see all these things start adding up. So there's time writing code, there's time waiting for somebody else to look at that code, so on and so forth. And what we ended up seeing is there was a lot of waiting. This is not minutes of waiting, this is hours and days of waiting potentially. And what we wanted to do was figure out how we reduce that time as much as possible. And more specifically, we're trying to figure out how do we reduce or eliminate the amount of time that we're waiting on humans to do certain things. So our little red X's here are basically saying any wait time where we're waiting for somebody else to do something, we want to automate. We want to figure out how do we get rid of that process of waiting for somebody. So 2009, we see this potentially large problem that's going to really scale very widely across the company to benefit in terms of moving faster. These are not new technologies that you just go find off the shelf. So we actually ended up needing to build our own tools for this. That's actually what we're going to get into. But we ended up building all the pieces that were necessary to get that software delivered, to take that human element from taking so long and to really automate it. So that's really what we're going to talk about. But just to give you an idea of how much this has accelerated Amazon and what that means, what these tools have meant, I'm going to give you a number. 50 million. Every year, Amazon deploys more than 50 million times. So in the time that I've been talking, on average, we've probably deployed a few thousand times. I think that works out to, I stuck this in my note slide, I think that's 95 deployments a minute. So this is happening across Amazon, across thousands of teams. That's really part of the process of moving faster, moving the software development process faster to deliver more for customers. All right. So you might not be looking to get your organization to a place where you're deploying 50 million times a year or every 1.5 seconds, but you might be interested in making it faster than it is today. So that's what we're going to jump into now. But the big question that most customers have is, how do I get started? Now, you may be already using DevOps, so hopefully you'll see some pieces that you can use. You may be starting brand new. So I'm going to focus a little bit more on the brand new in terms of just learning about DevOps and talk about what are the pieces that go into that and what do we offer to help you accomplish that. We have 4 key services that we provide today that are fundamental building blocks of this DevOps process. And those are AWS Code Commit, AWS Code Build, AWS Code Deploy, and AWS Code Pipeline. We'll talk about those in more details. But these are really the key pieces. And these tools really came about from the internal tools that we built at Amazon to enable the DevOps model. And we'll talk about where each one of these fits. And there was a slide a little while ago talking about continuous integration and deployment and delivery. And I'll kind of talk through how each of these fits into that picture. So fundamentally, the development process is about source, building, testing, and production. That's an oversimplification. But those are the basic principles. So you have source code, you build that source code. It's not always built, but frequently built or packaged. You then want to test that code, and then you want to have it deployed. And that is the process. So let's talk about each one of the services. AWS Code Commit is a Git-based repository technology. So this is how your source code is versioned and controlled. So AWS Code Commit can be used on its own as its own source repository. It is just standard Git. And we'll show a little bit of that usage later on here, but fairly straightforward. One of the things that we do really well at Amazon in terms of the key qualities of services is scalability, availability, durability. So these are all aspects of of AWS services that are built into Code Commit. So this is a managed source repository technology, so you don't have to worry about running your own servers or worrying about scale. We take care of that for you. So that's the source aspect of this process. About a year ago, in fact, it was I think it was at reInvent last year, we launched a service called AWS Code Build. If you've ever run a build server or managed a build server, think of this as the managed version of that. There's no server for you to manage with Code Build. It is a service that is provided as a part of this process. You pay only for the minutes you use. So there's no infrastructure that you stand up. You literally submit jobs to be built. There's an output and a result, and you only pay for the time that it took to actually do the build process there. In terms of tests, you can actually go write your own unit tests. That can be part of your build process. But we also provide integration with third-party testing tools. So we have a number of partnerships that we've set up that let you quickly integrate testing into your overall process, whether that's some type of integration testing or some type of health check testing. We provide a lot of capabilities as a part of this process that are integrated. And we'll talk about this a little bit more with the last service I'll talk about. But before I get to that, now you want to deploy this code, deploy these built artifacts to production. So I talked about that 50 million deployments every year that Amazon does. We've taken that experience and that technology and delivered that in a service called AWS Code Deploy. And really what Code Deploy lets you do is it lets you deliver to any EC2 instance. EC2 is our virtual server technology. Or if you're running on another provider or you're running on premises, you can deploy to those as well. So that's Code Deploy. Now, there is a key service that now pulls all these things together, and that's called AWS Code Pipeline. The process from source all the way to production is really an orchestration of steps, and that's shown here in this diagram of source, build, test, production. Well, if you have source that's in built, and if there's a problem with build, you obviously don't want that to proceed, but if it is successful, you do want it to proceed. So AWS Code Pipeline is the service that stitches all of these things together and helps you move that along in an automated way. And we'll talk about that in a little bit more detail in just a moment. But there is a fifth service that we launched actually earlier this year that helps put this entire picture together. And you may have heard of it. It's called AWS CodeStar. So AWS CodeStar is really a layer on top of these services. Now, if you're using AWS Code Build or Code Commit or Code Pipeline or Code Deploy, you can use each one of these individually if you like. You don't have to use them all together. If you decide, for example, you want to use GitHub and Code Pipeline and Code Deploy, you can just use those pieces. These are very mix and match. We offer CodeStar, which pulls all these things together to take care of all the configuration and to take care of all the details that might normally be involved if you want to get up and running really quickly. And CodeStar includes the source, so there's a sample source. We'll take a look at that here in a minute. It includes the entire configuration of that tool chain of source all the way to production with your code pipeline. And it also includes the provisioning of your infrastructure, so the definition of the infrastructure where that application is running. So what it really enables you to do is start and run and deploy an application in just a few minutes. And we'll talk about that in more detail here. Okay, I mentioned we're going to do some demos. It's not quite the halfway mark, so I beat my own attempt to get to this before halfway through. But I'm going to walk through some demos here. If you see things that you have questions about, again, we'll have an opportunity to ask some questions at the end. But I'm going to go ahead and start some quick demos here. I'm showing you AWS CodeStar. It encapsulates everything, as I mentioned, but you can go use the individual services on their own. This is kind of going to give you the overview of those things. So if you visit the AWS console and go to /CodeStar, this is what you'd see if you'd never put together a CodeStar project before. I'm going to go ahead and click Start a Project here. And the first thing that we're going to give you is a set of templates based on your language, the compute environment where you run, and the application type. Now, CodeStar focuses on services, web services and web applications, as well as some other like static websites for this process. That's where a lot of this DevOps process is most beneficial. And I'll just show you a few of these real quickly. You can choose from a variety of languages, Ruby, Node, Java, Python, PHP. We actually added C#. That's not included here, but that's also available for .NET Core-based projects. And then if you're not familiar with these service names, that's okay, but you could choose where you want this application to be running. So AWS Beanstalk, Elastic Beanstalk is our managed virtual server environment. You can use Amazon EC2, which is you manage the virtual server yourself. Or for those of you who are interested in serverless technologies, we also support projects based on Lambda, which is, think of those as functions in the cloud that don't require a server. So I'll go ahead and pick one of these. We'll pick Node. You can just see this is an easy way to filter down. So I'm going to go ahead and pick a Node.js web application that runs on Lambda. Now, once you've picked your project, all you have to do is give this thing a name. That's the entire length of the process here. I'll go ahead and add a name. So you give it a project name, and then you hit Create Project. Once you've hit Create Project, we're actually now in the process of provisioning everything. So remember, there was the source code, there is the tool chain, and there's the infrastructure where your application is going to be running. Now, you're at some point going to probably want to edit that application, to edit the source code or edit some aspect of that application. So before we even get you started, we help you figure out how to connect to that project. We have integrations with Visual Studio, Eclipse, and of course you can just use command line tools. So I'm going to show you how that works here. And what we do is we give you sort of simplified instructions for just going ahead and getting started without having to jump out to documentation. So I'm going to go ahead and show you how that works. I'm going to go ahead and copy this. Let's see. We'll jump to the next slide, the next page here. So at this point, I have a repository that's been created. My source code repository, it's using code commit, has been created. It's in the cloud. And now I can copy that code down. I can clone that locally. And what we basically do is we give you you just paste this in, press. There we go. So these are fairly small projects to get started. It's just a sample, but demonstrates enough that you can see a running application. We'll go ahead and jump back over. But that's it. I've created the copy on my source code, on my local environment. So once you're done with that, the process of creating the application is literally just waiting for it to finish provisioning. And there we go. With CodeStar, we basically have now created all the source code that you need, the infrastructure, and the tooling, and we drop you into this dashboard that helps you understand what you've got in your project, things that are going to be useful as you continue this sort of DevOps model, this DevOps approach. So the first thing is I'm going to show you that there's an actual running application here. So I have this application endpoints. I'll click on that guy. And there we go. So this is a live application. I've launched a live application. It's running in the cloud. This is a serverless application. I mentioned I'm using AWS Lambda, but everything I've needed to get that application up and running is now there. So if you go and try this right now, if you go and try this after the talk, you will see something very similar. I think the only reason it might look different is I think the color of the background on this changes based on the time of the day, but you will see the Space Needle. All right, so we'll go ahead and close that. Okay, the application is now running. Another thing that I'm probably going to want to do is understanding what's there and get ready to make some changes to it. So let me show you the dashboard. So this dashboard we were just taking a look at includes a whole bunch of different pieces. There's some introduction element. Welcome to reInvent is the name of my project. I've got the endpoints. We've got a team wiki tile here. So this is something that you can go edit and add your own content. Maybe you have links internally that you want your team to be able to share. You can edit that. It's just Markdown. But down here, I've actually got this continuous deployment tile. And what this is it's showing the stages that I have in that flow. Remember I talked about code pipeline as being sort of this orchestration of steps. We've created that for you, starting from source to build to deployment. And the source is code commit, the build is code build, and then the deployment, in this particular case, we're using something called CloudFormation to do that deployment. But this all starts basically from a commit that happens. You commit code, and this process begins. Okay, so you've got this project set up, you're learning about DevOps. You want to actually go make a change to the application. What does that actually look like? Let's walk through an example. I switched here. So I'm back at my command line. You can use whatever tool you want to edit the code that's on your local machine. I'm going to use just a simple text editor. So let's go ahead and look at so I've got, in this directory, I've got a buildspec.yaml, index.js, a public folder, readme.md, and a template.yaml. These are all the pieces of the application. If you go look at the readme.md, you'll have more details about what's actually contained in that project. I'm not going to go over that right now. But I am going to show editing this index.js. The index.js file is the Lambda function itself. So if you've used Lambda before, this will look familiar. If you haven't, it's just code. So this is very simple. Our basic application that comes with CodeStar basically just loads a static page. That's all that you saw there. But it wasn't just a static page loading. It was the Lambda code loading that page from S3. So I'm going to go ahead and I'm going to make some small changes here, and all I'm going to do, let's see, I'm going to comment out that content that's being loaded. I'm going to, let's see, add some just plain string text. That is actually going to be the payload for my application. So I've now taken out the Space Needle, and I've now included just a simple string. And what you can see here is that I'm going to respond with a 200 status code. I'm basically going to toString the contents and specify the content type. So now what I can do is I can save this out. I'm saving this out. So I've saved this. I've now changed this locally. What I need to do now is add that change and commit that change, and then ultimately push it. So just add that change. I'm just going to add a simple message for what that change was. So I've committed that change. And now the last thing is to push it. Now you might not, I'm showing this for demo purposes, you might create a pull request instead of pushing this change directly, but we'll go ahead and Git push. All right. So at this point, what's happened is I've changed the code locally. I've then committed and pushed that code to my cloud-based repository. That is actually going to trigger the process for that application to start the build and deployment process. And if everything's successful, then we actually see a different application rather than our old Space Needle. Let's see, okay. So this deployment process, you can take different amounts of time depending on how complicated these applications are. I have sort of fast-forwarded through this because it takes about 2 minutes for that deployment process to happen, starting with source to build and then ultimately deployment. So let's go ahead and I'm going to switch over to the application. And there you go. I probably should have added a font size to that. If you can't see it, it says hello world in very, very small text. But that is the same application, just a few simple code changes, and that's automatically been deployed. So you could actually go visit this application yourself and see that that's there. Now, let's jump back to the slides. Now, one of the aspects that I talked about in the DevOps model is the ability for there to be communication and collaboration. Tools like code commit or Git-based source repositories are a fundamental piece of that collaboration. It allows teams to work together to make code changes and deploy those changes without breaking each other or having somebody go and touch production code and somebody else not know about it. So that's really what this is about. So we wanted to enable even more in terms of the collaboration aspect of DevOps in CodeStar, so we made it easy to add team members. Now, if you've ever worked with permissions and the authorization and authentication aspects of AWS, you know it's a very powerful piece of technology that allows you to really lock down specific pieces. But when you've got a whole bunch of pieces that you're bringing together, including code commit, code build, code pipeline, and the resources that are underneath that, that can be a fairly cumbersome process. So we've simplified that for those who are interested in this by adding a sort of coarse-grained team member add functionality. And really, we've broken it down into 3 key types of roles, kind of like an administrator, we call a project owner, a contributor who can change most things of the project, like they can commit source code and make changes to the application. And then we have basically those that are viewers, those that can see the entire project but can't make changes. So I'm just going to show you quickly what that looks like. So if you're in a CodeStar project, we have this little Teams tab on the left-hand side here. If you click on that, you'll see this project team page. And I'm the project owner. I created this project. But I want to go and add somebody else. And I'm going to add my friend Leo. So I can click Add Team Member here. Click down here. Now, Leo is a new user. Leo is somebody that I don't have a user for in my system. So what I need to do first is create an IAM user. If you're familiar with IAM, that is the foundational technology for authorization on AWS. Our team-based permissions is built on IAM. So this is not a different technology. It's using the same technology. We've just simplified this process for you. So I'm going to go ahead and create a new IAM user. What we'll do is we'll pop up just a little dialog. Now what we're going to do is take some basic information and we're going to help you create that IAM user rather than you jumping over to a different console and creating that user separately and then worrying about different types of permissions. So I'm going to fill this in quickly. Now I've added Leo here. I'm going to make him a contributor. So you got to make him a viewer or an owner or a contributor. I'm going to allow Leo to change code here. So now what I've done is basically added the basic information that IAM needs for me to create a user. And all I do at this point, I'm actually in the IAM console, but we've taken you all the way there. I can just hit Create User. And what that does is it creates the IAM user, I hit Close, and it actually pops you back. Leo now has access to my project. And more specifically, Leo has access to just the resources within this project. So maybe you want Leo to be able to use the account, but there are certain pieces of it that you don't want him using. The permissions that we've now applied apply only to the resources in this project. All right. Okay. Okay. So at this point, I've covered most of the foundational pieces of these services. We've talked about code commit, we've talked about code build, we've talked about code deploy and code pipeline. I showed you CodeStar, which sits on top of that. These are all the pieces that you can try out yourself. If you're just starting, CodeStar might be the place for you to start learning about things. If you're more familiar with these, maybe you're just looking for a build solution, a managed build solution that scales elastically, where you only pay for the time that you're using it. Code build could be the answer for you. If you're looking for a highly available and highly scalable source technology, that could be code commit. What's great about these is it is very mix and match. You use what you want to use. You don't have to adopt all the pieces together. You pick what you need, what you want, and you can start from there. If you're already, much farther down the DevOps approach and you've got a lot of existing tools, maybe you decide that you want, say, code build. You just want code build. You can use just code build. Maybe you're on the other end of the spectrum and you're just getting started and you want all of the things together. That might be where you start with CodeStar. So it's really up to you. It's this spectrum that really makes it easy for you to decide what are the pieces that you want. All right. There are some features I didn't show here. Let's see. There we go. That we've launched recently. Some of these are within the last few weeks. Some of them are actually in the last few days. So I just wanted to highlight those. If you've tried the existing code services before, and maybe there's a feature that you didn't get that you've been interested in, I just wanted to highlight a few. One that I didn't talk about in CodeStar, there's actually a Jira integration. So if you wanted to include your existing Jira projects with your dashboard, you can do that. We also added GitHub integration recently. So rather than using code commit, you can use GitHub. And that integration lets you create new projects using your own account, creating a new GitHub repository. That gives you visibility into the repository from your dashboard, but it also connects the code pipeline directly to GitHub. You can also view your issues and pull requests in the dashboards using that integration. Let's see, I think it was the 20th, so just a few days ago, about a week ago, we announced pull requests for code commit. For those of you who have used code commit, you'll know that this has been a long missing feature. We're excited to be able to tell you that you can now use pull requests with code commit, a very frequently requested feature. Code build actually now integrates with GitHub to do builds on pull requests. I think we announced that it was maybe 2 weeks ago. And then I think it was in the last week we announced code build support for VPC resources. So if you have an existing VPC, maybe you have code that already exists that you actually want to be built with code build, but you want to keep that in your VPC, code build now supports that. So those are some of the new updates that we have in the last few weeks. And wrapping up here, I wanted to point you to some other sessions that are happening this week. This was a 200 level session, so we drilled into some of the details. I tried to keep it a little bit higher level though. But if you're interested in more details, there are a number of talks that are being given by my colleagues about different aspects of what I've talked about here. So just highlighting some of those. Today, there's Achieving DevOps with Microservices-Based Architectures. That is at 1:45. Life of a Code Change to a Tier 1 Service. A Tier 1 service being an AWS service that is used by other services. Excuse me. 3:15. How to deploy and scale web applications on AWS at 5:30 today. So that's today. Just look for any of these dev titles for those types of talks. They're all in the Venetian. We've kept all the dev ones in the Venetian here. Deep dive on AWS CloudFormation. CloudFormation is our infrastructure source technology I mentioned earlier in the talk. If you're interested in the CLI, you kind of saw me using the CLI there for a second. You can learn more about that. Continuous integration best practices for software development teams. Really good talk. I believe that's given by my colleague Mark Mansour tomorrow night at 7. And let's see, the CLI was again on Thursday. I actually give this talk again on Thursday, I think at 12:45. And then Friday we have a final talk about deployment techniques for Amazon EC2 workloads using AWS Code Deploy. So that is it. If you want to learn more about any of these services, all of the web pages are easy to find for CodeStar, Code Build, Code Commit, Code Deploy, and Code Pipeline. Check them out. You can go directly to the consoles for many of these to try them out and get started. And with that, thank you very much for your time. Thanks for getting up early and joining me. If you have questions and you want to stay afterwards, feel free to step up to the microphone. Thank you very much.
Try that? Okay. So the first question I have is, do these pipelines integrate also with OpsWorks?
With OpsWorks. So are you looking for a specific type of deployment or?
A lot of times our deployments also require infrastructure changes based on data sources, think LDAP, stuff like that.
Got it. So his question was about AWS OpsWorks. OpsWorks is another AWS service that helps you manage deployments to your servers. So Code Pipeline actually provides a number of different integration points. So I talked about Code Deploy. You can also use CloudFormation, so you can actually have CloudFormation actions, so you can deploy new infrastructure. So that's, depending on what you're actually trying to deploy and change, you could use that. You can also use, let's see, there's a Lambda invocation that you can use. So if you have some custom steps that you want to carry out, you can actually use that. So as a follow-on stage, let's say after you get done building and maybe some unit tests, and you actually want to take some custom action, you can actually call your own Lambda function. At that point, it's your own code, so you can decide what you actually want accomplished. Those are going to be the best ways to do that. There isn't a direct OpsWorks integration. Out of curiosity, is it just you have some changes from code that you want to drive infrastructure changes to?
Some of it is that way. Some of it is because an application will require new custom schemas. So the products are separate.
Right.
But you still need to make sure that those two things go out at the same time.
Yeah, right. Yeah, the Lambda one might be the process there. Trying to think, several of the steps, like Code Build has pre and post steps, so you can basically run your own CLI commands if you want. So take a look at Code Pipeline with Code Build, Lambda, CloudFormation. Code Deploy might also have some pre and post steps that I'm not remembering right now, but that's going to be your best bet for those.
Okay, thank you.
Thank you.
Hi, I have two questions. One is, how does these services relate to AWS Local? That's one. And number two is, we run Scrum teams. Like, would you recommend in Amazon or like, in Amazon way, like, do you have all the skill sets within that Scrum team, whether it's DevOps and whatever is required to get thing done and out to production?
Got it. Two questions there, if I can summarize. Is the first one about SAM Local?
No, AWS Local.
AWS Local. I'm not as familiar enough on AWS Local, so I'm gonna skip that question for the time being. But if you wanted to wait, we can chat here afterwards. And then the other question, sorry, was about do you have all the expertise within the same team?
Yes.
Is that kind of the question?
Yeah.
That's a really good question. I actually get this a lot. If you think about DevOps, the DevOps model is really about accelerating and getting your process moving faster. That is really at the core of it. There are a set of practices that you can use that exist that you can learn from, but people take bits and pieces from different processes to put these things together. So, for example, DevOps is really about having a single set of individuals that have shared responsibility over both operations and development. And so you typically want both development and operations. Those are some of the big ones. Now, I have seen models where they add another layer, so they'll have like, a security person in there, or they'll have somebody that specializes in, web applications. It really is about understanding your own process and what it takes to get that deployed. Within Amazon, we tend to have, the DevOps model is pretty strong, and then it's not infrequently you have team members that have stronger areas than other team members, so you might have somebody that's a little bit more of an expert. I think that probably naturally occurs, especially the team sizes that we use. As teams get bigger, I have seen more specialization occur. Now, what Amazon has experienced is this two-pizza team model works pretty well. If you get to a case where a service is so large scale that you have so much infrastructure that you're sort of managing and monitoring, maybe it makes sense to have somebody who's a little bit more specialized on the operations part of it. So it really depends on the set of problems that you're solving in your particular process.
Thank you.
Hi, I just wondered if this product integrates with containers, Elastic Container Service, for example, and also whether the tools provide a mechanism to manage configuration data, like environment settings and things.
Got it. So the question about our Elastic Container Service, AWS ECS. So there is a reference architecture. You can go search for this. I think it's posted in the AWS Labs portion of GitHub. And what you can use is you can use CloudFormation to actually set up and deploy the ECS containers and all the configuration for that. So that would be my recommendation for you. Check out, I believe it's the AWS ECS reference architecture, and it uses code pipeline connected with source and build that does packaging, and then ultimately deploys that using CloudFormation.
Okay.
Does that answer it?
Yeah.
At least partially.
The second question was about the sort of configuration data. That's quite a common problem in DevOps, is where you manage all the environment-specific information deployed with an application.
Right. So this is like environment variables and whatnot. So this is an interesting problem. Again, there are many approaches that I've seen to this. If I recall, ECS, I think it may support environment variables natively. I think AWS Lambda supports environment variables natively. So there's kind of a two-part answer. Individual services may support things like environment variables. They may support that directly, so that can be part of your configuration. The other way that I've seen this done very commonly is within the code there will actually be a lookup call. So it's the same code that's running, and it will basically do a lookup for its stage and look for, let's say it's a DynamoDB table. So Dynamo is our NoSQL database technology. Let's say that you have one Dynamo table for, say, like a development or a beta stage, and then you have a different Dynamo table for the production stage. So the way that may work is for that given stage, the lookup will be dynamic, and so you'll actually get a Dynamo table back for that specific stage. So we see this happen in a lot of different ways. Somebody told me about a new tool that I'd never heard of last night that actually is a post step for setting environment variables locally. Can't remember what the one they were telling me about. So there's no one process. It really comes down to what is the process that works for your particular configuration and setup. But lots of different options.
All right.
Thank you.
Hi. Oh, hello. I'm very new to all this, and I'm used to working on a local laptop with Tomcat running, and I'm trying to figure out using what you've described, how I could do deploy code and then use a debugger in Eclipse, say, to step through the code and stop at breakpoints. Can you even do that?
Yeah, so if I understand the question is effectively how do I use a debugger in this cloud base? So that's an interesting question. It will depend on the type of application. So if you're using Lambda, Lambda is running in the cloud. We do have something called SAM Local, which is kind of a local version that you can run that sort of emulates some of this running in the cloud.
Okay.
If you're using, so you mentioned Eclipse and probably Java that you're using.
Yeah, I'm using like building a jar with Spring Boot app, that kind of thing.
Yeah, if you're running it locally, you should be able to actually set the breakpoints within your IDE.
Right.
I'm gonna also highlight in the Visual Studio integration that we have. Sort of similarly, you can actually run the applications locally troubleshoot and debug those things. Obviously, if there are references to resources in the cloud, you need to make sure that your current environment has access to those things, probably for your application to run. But that is possible. I will claim that it is not necessarily something that we've completely solved in terms of making that a seamless experience. So that is still something that, I think there's a lot of improvement that we can make there. But right now, the best bet is to use those IDEs that you're currently using to run it locally. You might have some code that checks to see if it's running locally to look up different types of resources.
Okay.
So, yeah.
So still really debugging locally and not
Yeah.
in
Yeah.
the, okay. All right, awesome. Thank you so much.
You're welcome.
Yeah, so one of the key element you said, microservice architecture, right?
Uh-huh.
So if it is a new application, it's easy to start and use all these tools in a more meaningful fashion. But if it's an existing application, and so you have two paths. You can remodernize the application, put into those components, and then use. But that's upfront taking a lot of time.
Mm-hmm.
Or you have another path. You can do incremental.
Mm-hmm.
You're using the tools for some kind of software delivery, but what we have found, once you have start using that incremental, you're kind of stuck because then your modernization takes a long time. Because then you are kind of hybrid, using the hybrid solution.
Right.
Right? So you're always in that situation because your benefit is limited when you start incremental. At the end of the day, you kind of stuck. But when you do modernizing the application, you take a long time because it's a lot of focus on. And so what do you suggest for a large enterprise? Because I think for new applications, it's always,
Right.
But for the existing application, or legacy application, it's kind of challenging because so many moving components and there's a lot of other aspects come into the picture. So what you have seen in the enterprise, they focus on both, or it's kind of mixed? Or
Can I ask you what this application is, just structurally?
yeah, so it's a suite of apps provide a particular functionality. Let's say order functionality. The portal, there is a web-based application, there is a ordering application, there is a database behind. This is all together a workflow, right? So in terms of, in fact, it's 5 apps, but it's suite of apps. It's not
Right.
like, yeah. So typically what enterprise does, they do app by app. It's not app by app, it's full suite you have to look at together, right? So, so this is web app, kind of front-facing customer and doing the ordering workflow. That kind of app is this.
Okay.
Yeah.
Well, I would, unfortunately, there's no specific answer I can give you without understanding quite a bit more, but I'll give you some kind of high-level guidelines. The first step could be moving to a microservices architecture. That by itself might be the right first step. I've certainly seen cases where customers have kind of started the process where they have an application that is, it's kind of unwieldy, it's hard to update, it's hard to maintain, they don't have good visibility on it, and they go and they maybe try to surgically take one little piece, and that isn't necessarily the best approach because it doesn't solve the sort of bigger problem. So one of the first things that I recommend is kind of taking a look at the overall process. What is taking the most time? I mean, this ultimate process is about moving faster, so you're trying to figure out where the time is being spent. Now, if the time is being spent trying to piece all these things together, the first step might be to actually move to a microservices architecture. That might be the right step. It really depends on the organizational goals. If this is an application that you're thinking about modernizing, no matter what, I definitely would say seriously consider starting by migrating to a microservices architecture before you start going down this path of trying to piecemeal things. So that is definitely a guideline. Now, if this is an application where you look at it and it's like, well, we're not going to be doing a lot of updating, but we want this to be a little bit more manageable, and builds for some reason take a really long time for somebody to set up and get configured. Maybe that is the single piece. You got to think about that journey that you're on. If the ultimate journey is full CI/CD, starting with, say, those practices of microservices is a really good place to start. It sounds like maybe you might be a candidate for that. But that also means for most companies, that's an initial larger investment that takes a little bit longer to pay off. And so that's kind of the bigger picture that we talk about with customers.
I think you're right. Means I think focus on the business problem. If your problem is just around getting the infrastructure built time, and not really paying attention to the application itself, you probably want to move into this just the incremental approach.
Yeah.
If it is a long-term directional applications, you want to focus more on doing the right thing to start.
Yeah, yeah. I will mention if your company has an account manager, or if you're interested in learning more, there's a Center of Excellence that you can search for. It's the AWS Center of Excellence. It actually talks about kind of some of the key pieces that you can think about in a little bit more detail than I've talked about here today.
Sure.
So that might be a resource that you go look up. I think it's the AWS Center of Excellence that you can go look for.
Sure.
As maybe a starting point there.
Sure. Thank you.
Thank you.
Yeah.
Great. I'm getting told that there's probably a talk in here right after this, so I'm going to take one more question, then I'm going to head out in the hallway and we can talk more. Go ahead and ask a question if somebody's got one.
All right. So the new feature of pull requests on code commit looks great.
Great.
Especially because our private PR count is getting up there. So my question would be, do those pull requests integrate with code build for things like commit statuses? Like, so you've got your pull request, and then the commit goes off to code build, and then you get some sort of status notification in that pull request?
Right. I will say not yet.
Not yet. Okay.
No, but we are aware that many customers want that capability.
Cool deal.
Great. Thank you. All right. I'll be out there. Thank you very much for people asking questions.